Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. Presently we are studying marine auxiliary systems. In this lecture we will first learn about the operation of axial flow pump which is used to supply the cooling water in the main condenser on steamships in conjunction with scoop injection system. Next, we will study the working principle of liquid ring air pump with diagram and animation. Finally, we will see the priming arrangement of centrifugal pump with attached vacuum pump and understand its operation. Let us now go through each of these topics one by one in the following slides. Axial flow pump and scoop injection system. This sketch shows the layout of engine room bottom platform of a steamship. Main steam condenser cooling system employs an axial flow pump when the ship is around the port and a scoop injection system while the ship is on its sea passage. The axial flow pump uses a screw propeller to axially accelerate the liquid. The outlet passages and guide vanes are arranged to convert the velocity increase of the liquid into pressure. Ship's propellers and thrusters also work on the same principle. Screw propeller is operated by the drive shaft rotated by a prime mover which may be electric motor or steam turbine. The drive shaft is supported by a thrust bearing and leakage through the gland is prevented by a mechanical seal. The pump casing is split either horizontally or vertically to provide access to the propeller and thrust bearing. The main condenser requires low head, typically 2.5 to 6.2 meters at high throughput such as 2800 to 9500 meter cube per hour, for which axial flow pump is most suitable. Due to low pump head, the condenser is located at the bottom platform in the engine room and the flow of seawater through the tubes takes a single pass. Low pressure turbine is mounted on the condenser which directly exhausts the steam from the top of the condenser shell. Axial flow circulating pump is started before entering or leaving the port. Similar to propellers, axial flow pump blades are subjected to cavitation, especially when operated at high speed. When the ship attains normal speed, circulating pump is stopped and the scoop injection takes over. The pump idles during the scoop injection and offers low resistance. Liquid ring air pump. This sketch describes the working principle of liquid ring air pump which is used to prime the centrifugal pump as they cannot handle vapors. The liquid ring air pump consists of an oval casing inside which a circular bladed rotor revolves. The rotor draws sealing water into the oval casing through a supply pipe from sealing water tank. The rotating rotor throws water to the periphery of casing where it forms a revolving liquid ring along the oval inner surface. This liquid ring seals the rotor blades and alternately recedes from and reapproaches the rotor hub twice during each revolution. Its effect is to form a series of reciprocating water pistons between the blades. As the liquid ring moves outwards from the rotor hub, a suction stroke is created, and when it moves inwards, a compression and discharge stroke occurs. Suction and discharge ports permit the air to be drawn in from the main pump suction and expelled through the discharge ports to the atmosphere. Movement of air in the whirlpool. This sketch shows the movement of sealing water and air in the oval casing. Sealing water is thrown out by the vane rotors to the periphery of oval casing, as shown in the diagram. Sealing water is continuously circulated from the sealing water tank. Excess water is returned to the tank along with the entrained air. Fixed hub forms two sets of suction and discharge ports. Suction and discharge ports allow air to be drawn in from the main pump suction and expelled to the atmosphere through the discharge ports. This arrangement is provided on bilge, ballast, and general service pumps. The emergency fire pump and the largest seawater pump in the engine room connected to emergency bilge suction. Animation of liquid ring vacuum pump. Liquid ring vacuum pump can have two designs, with a rotor in an oval casing or an eccentric rotor in a circular casing. As it is difficult to imagine the pumping action, this animation explains the basic working principle of liquid ring vacuum pump with an eccentric rotor in circular casing. The impeller throws the water just like a washing machine. The void in the center of the machine is an airspace. This motion draws in air molecules represented here with white balls through the inlet ports. When inside the pump, air is compressed as the water ring moves back towards the center of the impeller. The air is then discharged through the outlet ports as the water ring moves away from the center of impeller. Attached priming pump. This sketch shows the layout of a centrifugal pump attached with a liquid ring priming pump. The sequence of operation is described here. The main pump is driven by the electric motor, which is also connected with the vacuum pump through a friction clutch. On starting the electric motor, if the main pump is dry, vacuum pump automatically engages through the friction clutch. The vacuum pump starts rotating and draws sealing water from the sealing water tank. As the water seal is formed and pumping action starts, it draws air from the main pump casing and pump suction pipe through float valve, filter, and check valve. The air is discharged into sealing water tank, which is vented to atmosphere. When all the air is removed by the vacuum pump, it may also draw some water from pump suction. Excess water overflows through the excess water drain in the sealing water tank. When pump gets primed, water pressure acts on piston in the actuator and compresses spring. The operating lever disengages the clutch and vacuum pump stops. Check and float valves close to prevent the backflow of air in the pump casing. Pressure of the main pump opens the screw down nozzle valve to discharge water to the pump delivery. This completes the study of axial flow pump, liquid ring air pump, and layout of centrifugal pump with attached priming arrangement and sequence of its operation. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examinations conducted by Indian Maritime University. I am sure that the book will help students prepare effectively for exams and also support them in working safely with marine auxiliary systems. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found the tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.